Good morning all. I bought this on eBay. It says it's a PIC12F675. Let's take a look at what's inside. And yeah, it is a PIC12F675 Microchip PIC microcontroller sat in a little board, which appears to be that way around, with keys, a reset button and a couple of general purpose keys which you can link in to various pins on the chip. There are some LEDs there which you can also link into the chip, and a potentiometer for doing analog to digital conversions. And there's a power socket there and a cable provided which can put 5 volts from USB onto the chip. So I suppose the first thing I should do is power it up. So power bank with 5 volts coming out of it. Let's see what this does. And it does precisely nothing, which is what you'd expect from a chip which is not programmed. I must admit, I was kind of half expecting to see some sort of demo program running where it flashed lights or responded to the pot. I don't think I've switched this on. Right, well, having switched it on, it doesn't do much more other than put on the power LED. The two LEDs which are hooked up to 2 of the GPIO pins. Now, which ones are they? LED1 and LED2 go to GPIO, or GP0 and GP1. They're not doing anything, so my guess is that this is a completely unprogrammed chip. Now, the only way we're going to know that for sure is to attach a programmer and see if we can do a listing of the memory contents. So let me find one of my PIC programmers. Right, they're in this box here. So I've got a genuine Microchip PIC Kit 2. I've also got the genuine article Microchip PIC Kit 3. And the reason I say genuine article is you can actually buy clones of these things now. So that would be quite interesting. That's a board onto which you can put a chip, and it has pot and LEDs and a switch, usual sort of thing. And the PIC Kit programmer just clips on there like that, so that's pretty neat. What's all this? Oh, that's the connector lead for the PIC Kit 3. These are some prototype charge controllers, which is what I was using all this for back then. And now these are a couple of PIC Kit 1s. So this was the original. Oh, I've soldered on a connector there. This was the original PIC Kit 1 flash starter kit. When the flash memory PICs first came out, this was the original programmer board. I bought 2 of these in different colours. So this is completely obsolete now. I'm not even sure whether MP Lab, which is the IDE, the software environment, even still supports these. What's that? It's a relay with a transistor and a pot connected to it. Now this is the 6-pin ICSP header, so that's the in-circuit serial programming header. We've got VPP, that's the programming voltage, VDD and ground, program data and program clock. But it's odd that it's on a JST connector because those pins are very short. And that doesn't really fit in there very well. And it also fouls on the 2.1mm DC jack. So that doesn't fit in there at all. That's really completely hopeless. And there's no cable supplied which goes from 6-pin JST to a 6-pin standard 0.1-inch header. So I think what I'm going to do actually is take that connector off and put probably a right angle 6-pin header on there instead of this JST. It just seems really the wrong kind of connector. So I think the easiest way to remove this is to remove the plastic shell, if that'll slide up, and then I can remove the 6 pins individually, get those holes desoldered, and then find a header to connect on there. Now, I'm not sure whether I'm still going to have problems with the, with the DC jack here. If that connects on there, oh no, that's probably okay. And also, I keep putting this on like that, but I've got a funny feeling that VPP is pin 1. So actually that's going to go on upside down, which is another real setback. Well, not setback, but bad design really. Why didn't they have it so that was face up? I better check that actually. Pin 1 on the programmer, I think goes to VPP. Let's check that online. So I've done a Google image search for PIC ICSP, and there is one here I can see, but you are getting also AVR ICSPs, which is again 6 pins, but in 2 rows of 3. Because of course the AVRs are so much more popular because of Arduino than the PICs, but I think that one there will tell me what I need to know. So let's click on that. Oh, that's Wikipedia. And yes, there's the pin 1 indicator, and it does indeed go to VPP. Pin 6, the one at the other end, says aux not used. Now I've got a feeling it is used for something, but I can't quite remember what. Or it was intended to be used and then wasn't for some reason. There is the 12F675, that's the chip we're working with. It's the same 8-pin layout as the 629, which doesn't have analog to digital. And it's the same as the 683. This is the one I used in the charge controller. And this has the addition of PWM. The 675 doesn't have PWM. Here's a representation of the PIC12 or the PIC12F675. So yeah, VPP to pin 1. Right, now while I'm pointing at the screen, let's just look at where this thing came from on eBay. It came from ASP eZone and was $10.21. That seems like rather a lot. I'll check the item I purchased in a minute. Free shipping, and it's described as a 5-volt PIC12F675 development board, learning board, breadboard. Oh yes, I actually paid slightly more. Okay, we'll forget that then. But yes, pin 1 is VPP, so that actually is going to connect upside down. Now, shall I have pins coming out the bottom? It would be okay, except that when that's going to be on its button, so maybe I'll program it with it upside down, pins coming out the top, and I'll just have this thing sat upside down with this on the bench, because I want to be able to see these programming lights, because I think they flash when you're programming. So yeah, I'll just have this thing upside down. I think I'll go for that. Right, some angled headers. Yep, they're angled. I want 6 pins of that, 4, 5, 6. So that's my angled header. Right, let's put a bit of water in my soldering iron, and this has to be the mankiest bit of sponge. I must go to the pound shop and buy some sponge, because that is really on its last legs. Now, you don't want to watch me struggling to get these pins out, do you? Nobody wants to watch that. Oh, you do? Oh, okay. Well, I'll film it then. So while the iron warms up, I think what I'm going to do is just attach these inverse tweezers onto each of these pins in turn, and then just heat it up from this side and kind of push down on there to try and get it to just drop out with the minimum amount of disruption to the onboard pads. How's this coming on? Yep, not far off. Now, while my iron warms up, I just wanted to show this. I've actually bought this. It's a PIC12F675, but it's a clone. You can see there's no Microchip logo on there. It's $11.93. This one came from Moon River 1980. But I've also bought a PIC12F675 clone, because these are a bit cheaper, $8.45. This one came from Alice. So when the PIC12F675 and the PIC12F675 clones arrived, I can see whether these clones are actually any good. And if they are, then it makes this little demo board and one of these clone PIC kits a viable purchase option, and then you can start experimenting with programming Microchip PICs. Right, iron should be hot. Let's see if these will just drop out. Oh, yeah, that one did. That looks like it's going to work. But was that just first time lucky? No, that works consistently. Excellent. Right, there's my right angled header soldered on there, replacing the JST. And I just have to remember that when I'm programming, that must be connected upside down. It's slightly annoying that. Also, this blocks the power socket a little bit, but I don't think that's a problem because you can get the programmer to supply power to the board. I think there's an option in the IDE for switching power from the programmer onto the target system. So let's plug this in and take a look at the IDE, see what we can see if we can read the contents of this chip. So from my PC, a reasonably long USB. Now this is a USB mini because these are of such a vintage that they both use the mini type connector, not the micro. That's plugged into my computer, but it's not. It's a bit tight. It's not. I'm not running the IDE yet, so that just puts power to this. The power LED has come on. Let's run up the IDE. Right, here's the IDE. This is MPLAB X. It may not be the latest version. I've got 2.35. I've no idea if this is the latest version. I could probably do a version check. But the last time I used this was obviously for the 10F322. That's the little 6-pin chip. It was a little SOT23 device, and I used some of the core independent peripherals as I remember it. This I was obviously using the PIC12F675 because that's listed as my debug tool. If I click on that, there's the source code for that particular program that I wrote at that time. So that none of this is appropriate to what I'm doing now. I think I'm going to have to click this new project button and create a new project for the 12F675. So I'm going to do that off camera because this is probably going to take me a little while to work out what I'm doing and where I am. But when I get to the point where I can list out the contents of this chip, I'll come back. So when I clicked new project, it actually went into some sort of wizard. So I've had to select, all this stuff. So it's a mid-range 8-bit MCU, PIC 10, 12 or 16, and specifically this one, PIC12F675. So let's do that. Supported debug device. Ooh, what's all that? Well, I don't know what that is, so I'm going to have none. Aha, programmer, PIC2. Now, can it actually see that? Is it actually seeing that device by virtue of the fact that I've plugged it in? I suppose I could try unplugging it. See if that goes away. Yes, it did. Okay, plug that back in again. Will that reappear? Yeah, so this is obviously the device that's plugged in. So that's going to be my programming device. Oh, compilers. Oh. Actually, of course, I don't want a compiler because I'm going to do this in PIC assembly language. So I actually want the assembler, which is that. And now I need to set up paths and decide where it's going to go. So let's do that. Right, so I appear to now have my 12F675 test project. I probably don't have any source files yet because I haven't created any. It's saying that my device is the PIC12F675, that's the chip I'm using. And it's also saying that my debug tool is the PIC2. That's the one I've got plugged in. So now there's a button there which has an arrow coming up from the chip to a little page. So my guess is that is some sort of read the contents of the chip type thing. Unexpected device. Oh, this is going to be fun, isn't it? Right, unexpected device, probably because there's no device because it wasn't actually plugged in. So what I need to do is plug this in pin 1. Must get this right. Don't want reverse polarity on this, so it's upside down. Oh, why have all those lights come on? That's odd, because that means that the GPIO outputs are high for those two pins. That's a bit strange. What does the on-off switch do? Nothing. Okay, let's see if I can read the device now. Well, now I've read the contents of the program memory, and yes, there does seem to be some code in here. There's a little bit of sort of startup code here, and then it says go to 3B7. So let's go down to 3B7. Oh, and yes, then there's a load of code here. So it does look like there is something in this chip. And there's lots of mention of GPIO. So it looks like there's some code in this chip which will do stuff on the I/O pins. How come it didn't appear to do anything? So plugging power in from the power bank, what I've discovered is that's the power switch that puts on the power LED, but keys 1 and 2 actually turn on LEDs 1 and 2. Now isn't that fun? Does the pot do anything? No, the pot doesn't seem to do anything. It doesn't vary brightness or anything like that. This chip doesn't actually have PWM, but you could do a software implementation of pulse width modulation for brightness control. But no, it doesn't seem that the pot does anything. I suppose we could look through the disassembly of the code and see whether there's any mention of the analog to digital converter. But it does certainly seem to have a demo program. All it does, though, is respond to these keys and turn the LEDs on and off. Yeah, it's kind of fun, I suppose. But there does seem to be a lot of code in there if all it's doing is reading 2 keys and controlling 2 LEDs on I/O ports. There does seem to be a lot of code, but I don't know. Assembly language, I suppose you do need lots of instructions to do fairly basic things. Now this one here, add literal W, the value FF, hexadecimal, is actually unprogrammed space, because unprogrammed program memory locations show up as 3FFF. This is 14-bit program memory. So FFFF would be if it was 16-bit program memory, but it's 14, so it's 3FFF. And just so happens that the disassembly of all ones essentially is add a literal value to the W register, the literal value being FF hexadecimal. Now, I've been fiddling about for quite a while trying to program this chip with my own code, and I've finally managed to do it, and in fact I've just erased it, so there's no code in there at all. Well, interestingly, there is code in there. It's that add literal to W FF. So in fact what's happening is it's just running that instruction repeatedly. It's not doing anything, but the W register will be changing. What's interesting though is, and of course being blank now, these 2 buttons don't result in LEDs coming on. But what's interesting is if you plug the powered up programmer in here, as well as the power LED coming on, the GP0 and the GP1 LEDs are also coming on, but dim. And I think what's going on here is that program data and program clock, which are those 2 pins there, so it's the 2 there with tracks running out of them, they are routed round to these 2 pins, which if you look on the board are GP0 and GP1, and those have the LEDs on them. So probably what's happening is inside the programmer, when it programs the chip, it'll put VDD and ground on and probably put a high voltage on VPP. I can't quite remember what the programming spec is. Then it'll waggle the program data and control clock lines. And possibly these are pulled high with pull-ups inside this program. It's hard to know. But certainly they seem to be on dim. So when programming in the chip, you're probably meant to take these 2 links off so that there's no loading on these 2 pins. There are all sorts of rules about what you can attach to various pins in order to do in-circuit serial programming. And I'm probably breaking those rules. But anyway, it is programming, and I have blanked the chip. So now I'm going to program in my own bit of code. Now I've had to go back to MPLAB IDE version 8 because I was having all sorts of problems with MPLAB X. It suddenly started not seeing the programmer and doing weird things. But in this one I am at least getting it to work. Now here's the current contents of the memory. It is all blank, and in fact if I click this button here, that does a read of the memory, and it is indeed all blank. It's all 3FFF. Here's my source code file. It's extremely simple. It just says move the contents of the W register into file 3, move the contents of the W register into file 5. Don't worry about that for the moment. What I want to do now is a project quick build. Oh, where's my source code? Yeah, there's my source code. Did I not save it or something? Project quick build. Ah, okay. So that's built. I'm getting a few warnings, but not enough to cause a problem, and it says build succeeded. And in fact, it then did a read or a verify of the chip, and it's pulled out the first 2 bytes of program memory are now 83 and 85, which correspond to these instructions, move W into file 3 and 5. We've got a disassembly, which is showing that those instructions have indeed gone in, and the rest of the program memory is still blank. So that certainly seems to have worked. Let's see what the result is on the PIC itself. And nothing seems to be happening. I've got a funny feeling I didn't do a program, did I? Those LEDs are being pulled up by these pull-ups, as I suspect. Let's just try it with 5 volts. No, nothing's happening. So let's put the programmer back on. I think I made an error there. Yes, that was deceptive. Although it did a build and showed the code as having those 2 instructions. In fact, if you do a read from the chip, which it's just done, no, they're not programmed. So now I needed to do a program to the chip. Read from the chip. Still not programmed, so perhaps I need to quick build this again. Project quick build. Now it's showing those as having been altered, but I think that's in computer memory, not in PIC memory. So now I'm going to do a program. And it appears to have done a program. Now let's do a read back from the PIC chip. Oh, unexpected device. Not sure what that means. Right, so the read back from the chip now is showing those 2 instructions in it. Will it actually do anything? And yes, it is. We've got actually a flashing LED. Which one is it? D1. No, doesn't it say which LED? Oh, well, LED 1, I suppose. Where's the other one? D2, yeah. So LED 1 is flashing very slowly and a bit chaotically. I think the other one blinks. That one blinked off. And I think this one blinks every now and again, just very briefly. But it is doing my flashing LED program. Now that flashing LED program is a bit of a swizz because it's only 2 instructions long and it doesn't really flash the LED in any sort of controlled way. It's a bit uncontrolled and chaotic, but I just wanted to get that program in so that I can see that I have actually programmed this chip and it is actually doing something. And yeah, it appears to be doing something. Let's switch it off and back on again. LED D1 is actually switching on and off. Interesting. So I think I've achieved my objective today, which was to connect a programmer to this board. The JST connector was really not very practical for that, so this new header seems to work better. To erase what was in the chip, and we discovered that there was something in the chip where it was looking at these 2 keys. It's not doing that now because I've put my own program in this chip. To put a program in this chip and make it do something, which is this LED flashing program, this rather chaotic random LED flashing program, but it is at least doing something. And so now what I can do is use this and those clone programmers, the clone PIC12F675 and PIC12F675, to start a series of Microchip PIC programming tutorials if people are interested in that. And of course, you know, the first programming tutorial I'm likely to do is flashing the LED in lots of different ways. Not probably this way, although perhaps at one point I'll go into how exactly this program works, or sort of almost works. But yeah, if anyone's interested in some Microchip PIC programming tutorials, then perhaps that's what I'll do as a follow-up to this video. But for the moment, I think I've done what I set out to do, so cheerio!